Hey everyone, welcome to our lesson on solving exponential and logarithmic equations. When we're solving an equation, remember we're trying to get our variable isolated or alone by itself on one side of the equal sign. And to solve this particular type of equation, we have a number of approaches we can try. We may need to take the log of both sides. We may need to take the natural log of both sides. We could also approach these algebraically by changing forms, and that is from logarithmic form to exponential form or backwards. We could also solve them graphically. So what we want to do is we want to just take a look at each example we have and decide what would be the best way to approach that. And I'm going to show you one of each type. So our first example here is one where we're going to need to take the log of both sides. And the reason for that is because if you notice, the variable that we're trying to solve for, the x, is trapped up in a power. And to solve for a variable, we will usually take the opposite operations, but we cannot do that in this case because it's trapped. So the log allows us to use the property that moves powers down in front as coefficients. So if we will just take the log operation of both sides here, take the log of the left-hand side, log of the right, then I can move that x minus 1 power down to the front of that term. Right here. So let's rewrite that. X minus 1 log 2 equals log 68. Now this is really nice because our calculators have the capability of calculating that log operation. If you'll look for the log button, you just simply type in log 2 and it will give you a decimal value. Same thing for the right hand side, log 68. So when you do that, we're going to replace those values in where you see these. So this one is approximately 0.301. We're going to keep everything else that we have there. And log 68 is about 1.83. So we're going to continue to solve. We have ugly decimals, but that's okay. Our goal is to get our variable by itself, no matter what we end up with. So we're going to distribute on the left-hand side here. We need to distribute that 0.301 to the x and the negative 1. We'll have 0.301x minus 0.301 equals 1.83. Continue to solve here. We're going to need to add our 0.301 from the left. Right, that's going to go away, and then we have 0.301x, 2.13 approximately. And our last step to getting x by itself is to divide by that 0.301 attached. Okay. And when we do that, it's approximately 7.09. So we have now solved for x, and we did that by taking the log of both sides so the power could come down. All right, here's another example where that same approach would work. However, the best thing to use here would be to use the natural log of both sides. And the reason why we're going to do that is because we can see an e, that special number e sitting there. E is the natural base of a natural log. So anytime you see that, you can go to natural log, and that will make some things calculate more nicely. When you take the natural log of its base e, that equals 1. So it just makes for a nicer calculation in your problems. But you can still use regular common log, and it would work just the same. So natural log of the left-hand side equals natural log of the right-hand side. And remember what that allows us to do? That allows us to move the power down to the front of that term, so it's no longer trapped. Natural log of 2 equals 3x natural log of e, which is going to end up being 1, so we can cross that out. Okay, so in our calculator, we're going to look for that ln natural log button. I'm going to type in ln of 2, get around 0.69. Set that equal to what we have left on the right-hand side, and divide by our 3 to get our x by itself. That's what we want to do. We want to solve. And it's approximately 0.23. Very easy once you have taken that log operation. All right, a third approach that you may need to use is to switch forms. This is an equation in logarithmic form, but there's only a log on one side and not on the other. So what we're going to have to do is get it out of log form so we can solve. We could solve if there was a log on both sides, but there's not. So to rearrange to exponential form is going to be our best approach. So we're going to take our base. These other two things get switched in their position. So base raised to the second power, set that equal to x plus 1. And this is the same equation. We haven't changed the value or anything. We've just changed the look so that we can solve for x. This is the exponential form of this log equation. So I've got 16 equals x plus 1. Need to get x by itself, so we're going to take away 1 both sides. X equals 15. We have our solution. All right, the last approach we talked about was solving graphically. You can solve any system of equations graphically, whether you've got 2 or 3, as long as you graph them all and look for that intersection point or region. So that's what we're going to do. We're going to graph 2 log x and 3 log of x, and we're going to see which point matches both. Which point do they share? Where's the intersection point? When you use your graphing calculator to do that, you will have 2 pictures, something like this. 2 log of x here, and let's get a different color for 3 log of x to see the difference. Would look something like that. Starts in a little lower but ends up a little higher. Okay, so the intersection point that you will find is here, and that is the x value. That's the solution that satisfies both equations. So 1, 0 means the x value is 1 for the solution there. Solving graphically, you just have to look for that point that they share. So this is going to conclude our lesson on solving exponential and logarithmic equations.